Hopefully you can hear me. Hello and welcome. This is MAE 113, Calculus for the Liberal Arts. I managed to put greetings in the live chat, so feel free to post in there. Again, being respectful, it's online, the world can see it. Be respectful of one another. And I think that there's an automatic monitor on there as well. So, but first of all, can you hear me? That's the first question is, I'm going to give a thumbs up or something in the chat so that I can see. But that's the first question. Otherwise, I have to figure out what's going wrong with the audio. Okay, perfect. Now, the other thing too is while this is YouTube and while I do have it on a low latency, perfect, yes, I see everyone's good. While I see there is a little bit of a delay in here, so I'll try to keep an eye on the chat as much as possible. If there are questions, feel free to answer your colleagues. The other thing that, yeah, so there's probably like, I don't know, I think I counted between 20 and 30 seconds. So it's, I'm a little bit ahead of you in terms of time. So again, this is MAE 113, Calculus for the Liberal Arts. This is winter term 2021. My name is Richard Kohar, and there's my email address. It's very easy to remember. It's richard.kohar@rmc.ca. We're going to have lectures Monday, Tuesday, Thursday from, well, we're in our period right now, from 4:40 to 5:30, and Tuesdays are a double period, and we have a single period on Thursday. So in the double period, we'll talk a little bit more about that. Calculus is a broad topic, and in this course, it's an introductory level. Oh yes, and Dr. Haddad has joined us in the chat as well. So feel free to also ask him too. I think there was one person who was asking me about French. My French is very basic. And so if there is words, feel free to ask what they are in English to have somebody else translate in French, or Dr. Haddad is here momentarily. So again, this is an introductory course. We're covering the basics. We have functions, limits, derivatives, and integrals. Functions you should have seen already in 103. Limits, we'll talk a little bit more of that. Those are kind of it's a fundamental concept to calculus in terms of what we'll deal with these other two concepts here, derivatives and integrals. The main reference is Marsden and Weinstein. This is Calculus 1. It's published by Springer Verlag. It is a second edition from 1985. Don't knock it until you try it. It is a decent book, and I will switch over to just what it looks like here. Your screen one. So first of all, this is what the course website looks like. You should be having access to it. Here's section 2, Calculus for the Liberal Arts. If you are wondering about that papery copy that I have right here, you can download it there. There's this course syllabus. The textbook is freely available. It is published. I think it is now out of print, but Caltech Library has it available. So if you were wondering, it's a legit copy. There's Calculus 1 out. The nice thing about this is that this book also comes with solutions. So there's a student guide here. So you can be able to look up what the solutions are for the odd exercises. Every textbook, even mine, has typos. There is no way to get around it. They seem to creep in. So there is an errata, but the nice thing about having a book that's a little bit older is that it's tried and tested, which means that there is a mistake. Probably somebody already found it and it's been listed already. I've tried to make this course webpage week by week so that I can put a link to the YouTube live stream. You can click it there. I don't plan to delete them after I'm done, so you should be able to view them after the fact. So again, here's the calculus textbook that we have. You can download it. It's 20 megabytes, so I can't send it directly through email, unfortunately. Our email server will block it on me, so you have to download it through Moodle, or you can download it through that Caltech library link. It's a straightforward textbook, and I think it's good level for people who are in this course. In this section in particular, the majority of the students are taking business administration and economics. So I think that we'll end up covering the majority of this textbook here. Well, let me just keep going through some of the course outline first, and then we'll kind of talk about what are the topics. So again, I mentioned what the textbook is. There could be additional handouts that I give out. Those will be posted on Moodle, or I might send them out by email. Those are two of my main methods of sending you information, is through the Moodle website or through email. I sent an email out already. Make sure that you got it. If you don't, you should send me an email saying, like, why didn't I get this email? And it might be that you're not registered in the course. If you're not registered, that's also an issue. Make sure that you're registered in this section. What I plan to do is have office hours. Here's Thursday. I'll have it for about 2 hours after the Thursday lecture, from 1 to 3. Or you can send me by appointment. I will set up something. And this will probably not be done on YouTube. That way you can see face to face. We can have it in a group session. You can ask me questions, and I'm not sure which method we'll use yet, either Big Blue Button or a Zoom call or something like that. The prerequisites for this course is MAE 103, or you need to have permission of the department to be in here. Attendance is mandatory for all scheduled classes. This is a little bit of a boilerplate from my standard outline that I usually give. The reason being is, well, everyone is spread across Canada. You're all in different time zones. We were expecting to be a little bit more accommodating by the fact that we're all in different time zones. So the idea behind that is that if you can't make it or it's too early, you should be able to replay it. The one caveat is do not try to put this off. Don't skip a class if you are able to attend. The reason for that is no one wants to listen to 36 hours of lectures by me, before the final exam. I don't even think I could handle listening to myself for 36 hours straight, let alone trying to study. So make sure that you keep up on the work, you are following along on the pace of the lectures. And I have a question. It says, when was the email sent out? I sent it out probably about maybe 2 or 3 hours ago. Let me just double check. Of course, the email seems to have locked up, but it was probably about an hour ago, about maybe an hour or two ago. So just to send out the fact, here's the YouTube link, and also make sure that you're checking out the Moodle page. So the course mark ends up being broken down into basically 3 categories. You have quizzes at 30%, you have a test mark that makes up 30%, and a final for 40%. So the 2 tests are equally weighted at 15% each. We will be giving out problem sets each week, and these assignments are designed to encourage you to keep up to date with the material. I don't mark the assignments, but the idea behind them is that we'll probably pick questions similar to what you've seen on the assignment, and then we put them on a Moodle quiz. Again, it's designed for you to... Okay, there's somebody who said, I've registered in the class, but did not receive an email from you. Okay, can I ask if anyone... Okay. Yeah, I sent it out through the master class list. Now it could be an issue for me. It could be an issue on my side that somebody, yeah, okay. Okay, so it looks like that the master email mailing list isn't working at the moment. So again, make sure that you are getting your course materials through Moodle, and it's good that most of you are here anyways. Okay, so I will have to check on that. Partly, I think it's because they changed sections. I was originally teaching section 3 and they moved me to section 2, and so I'm sure it's taking some time for the system to update or something. I'm not sure at the moment, but I will get there. Right. Quizzes, they're mandatory. We're going to be doing them weekly on Tuesdays at the beginning of the class, so probably like 10 minutes, and then we'll start the lecture. These quizzes will be based on the assignments, and they serve as an indication of your progress. There are 2 tests. And this is kind of important right here. Any unauthorized absence from the test or exam may result in a mark of 0 being awarded. If your absence is authorized, please provide to the instructor the appropriate documentation to support your claim. Make-up quizzes or tests will not be given. So if you legitimately miss one, then your final mark will be calculated using other marks and a different weighting scheme. A 3-hour final exam will be scheduled by the registrar's office during the winter examination block. Please be aware that according to the Academic Regulation 10.2, the instructor may refuse a student permission to write a final exam in a course if the requirements with regard to coursework have not been met. Meaning that if too much coursework has been missed, or something, basically you've missed a lot of, like, you missed a lot of tests, or you missed a lot of quizzes, or there's no work for us to basically evaluate you on, then there can be refusal. Again, that is, I wouldn't say that's the norm. That's not normal, but these things do happen where some people have missed a lot of work, and so they weren't allowed to write the final exam. The last thing for me to mention, academic integrity. Academic integrity violation, including plagiarism, cheating, and other violations of academic ethics, is a serious academic infraction for which penalties may range from a recorded caution to expulsion from the college. The RMC Academic Regulation Section 23 defines plagiarism as, quote, using the work of others and attempting to present it as original thought, prose, or work. This includes failure to appropriately acknowledge a source, misrepresentation of cited work, and misuse of quotation marks or attribution. It also includes the failure to acknowledge that work has been submitted for credit elsewhere, end quote. So in particular for this class, the use of calculators, mobile phones, slide rulers, abaci, and other calculating devices are strictly forbidden on all quizzes, tests, and final exams. I'm not naive. For the Moodle quizzes, we won't be able to really inspect that you're not using materials that are not authorized. My only thing that I can tell you is that you'll be cheating yourself, because on the tests and the final exams, they will be watched, and you won't be allowed to use them. So again, use the quizzes as feedback to gauge your level of knowledge, and so that you know at what level your preparedness for the tests. Okay. So going on for that, okay, that was a lot of talking, but that's the course outline. If there's any questions about that too, just you can throw them in the chat. Let me just jump back to this book. So we'll do a little bit of a review of fundamentals. So there's some basic algebra, intervals, laws of exponents, straight lines, circles, parabolas, functions, and graphs. Then we move on for chapter 1. We'll introduce you the idea of limits. We then move on to doing derivatives. We do rates of change and chain rule. There's rules in terms of like what we do with derivatives. Then the next thing, and I should also point out, because we have economics and business administration, right? These are not financial derivatives, right? These, we're talking about mathematical derivatives. A slide rule. Oh, I can always pull out one. It is a treat to be able to try that. Rates of change and chain rule. So again, there's different rules that we can use basically to go a little quicker than trying to use first principles to solve problems. Then we go on to graphing and minimum and maximum problems. These are kind of important because minimum and maximization are kind of the bread and butter of optimization. And again, when we're talking about economics or business administration, we want to either maximize revenue or we're trying to minimize cost. These are the dual problem, and these are important to try to make more money or to lower cost. Then we move on to the integral. We skip chapter 5 in this course. We don't cover trigonometric functions. These are trigonometric functions are useful in engineering applications, and perhaps if you were going into time series analysis, if you needed to use some spectral analysis or you needed to do some more Fourier analysis transforms, chapter 5 may be useful, but we don't cover that in this course. Chapter 6, then we finish off with exponentials and logarithms. We might circle back, depending on how much time we have, we might circle back and do a little bit more integration if time is permitting. If we learn to use a slide rule, are they excluded like calculators? Yes, because that's what we had said so in the course outline. Slide rules are for those, basically it's a ruler and you slide it so that you can do calculations on it. Some people were using it for logarithms or for doing other calculations when we didn't really have electronic calculators back in the day. This book is part of a series of 3 books, so you don't have to worry about that. The nice thing about this is, as I switch back to the camera above, there are some orientation quizzes. So I think the first thing that I'd like to do is, there's 3 quizzes in here. They do quiz A, quiz B, and quiz C. Quiz C is about trigonometry. So I don't think that we will do that, but I think perhaps just as to get our brain cells moving just a tad after the Christmas break, perhaps that we'll look at doing quiz B. And I'll do my best to talk through this as I'm thinking about it. The idea behind this is that if you did this yourself, these are questions you should be able to do. These look like that they are roughly 103 level, so we can always start off. And this is on page 14. So don't worry about if there are notes or something like that. If I'm writing, I will try to scan them and post them to Moodle, so don't have to, scribble down furiously. But if you are working along, that's okay. Page 14, and this is quiz B. And I should probably date it. Okay. And the other thing too is that when you're working through this book, which is kind of nice, is they'll expect you to be able to do this by hand or by mind, so that you don't have to really rely too much on technology. Again, it was the 80s. Not everyone was able to afford a calculator. So the first question that we had was 3/2 plus 5/4. So I'm going to leave the 5/4 and write this to have the same denominator. So I'm going to write this over 4. And so basically I'm multiplying this by 2. So 2 times 2 gives me 4, and 3 times 2 gives me 6. So 6 plus 5 is 11 over 14. And that's the answer that is in the back of the book. So that's good. I remember how to do fractions, which is something that you would like to know, that your 113 instructor is able to do fractions. Factor. This is very professional. So they ask us to factor this, x squared plus 3x. And so basically we're just doing common factoring. We have an x in the front here, we have an x here, so we can actually pull that out, and I'm left with, see, if you're thinking of this, you can have x times x plus 3x. So actually I can pull that x, and what I'm left, once I remove that x, is I'm left with just x plus x3. Okay, so that's the factoring part. Oh, good, and my passing score has to be 8 out of 10. So, I don't know, maybe I'll give up after 8. I have minus 6 times minus 3 plus 8 times minus 1. Okay, when you have two minuses, that becomes positive. 6 times 3 is 18. So, and then I'm left with minus 8 here. So I have 18 minus 8. So I have 18 minus 8, that's just 10. Oh, good. If a bag of sand weighs 80 kilograms, we're asked what 5% of the bag weighs. So 5% of 80 kilograms. Okay, this is like doing taxes again, when we used to have 15% sales tax here in Ontario. So the first thing that I would do is I would think of 10%. So 10% of 80, that's 8, right? I'm just moving the decimal place over by 1. So I've got 8. To get 5%, I just divide that by 2. So in the end, it's 4 kilograms of sand is 5% of 80 kilograms. Oops, and of course I went off the page. Okay. Number 5. So I'm just going to rewrite it as opposed to trying to keep it at the top there. So the next thing that they ask us is, we have 3x minus 1 over 2x minus a half. And I just wrote equals what? I think what they mean is that they want us to simplify this. So the hint that they say is to bring to a common denominator. What they mean that is, again, when we're talking about fractions, we have the numerator, and in the bottom we have the denominator. And so they said to find a common denominator. Right here I have 2x, and on the bottom here on the denominator here I have 2. So the only way to do that is a little trick in algebra that we usually do, is multiplying by 1. Now in this case, multiplying by 1 is a certain kind of 1, because what I want to do is I'll end up multiplying it. I want to do the bottom here, which is multiplying it by x, but I can't just make something up in thin air. I have to multiply by 1, and effectively that doesn't do anything. So x over x is equal to 1. So again, to find a common denominator, I notice that I'm missing an x on this side. So I'm just multiplying by 1 or x over x to get me that. So now I can actually extend this the entire way. So I have 2x and I have 3x minus 1 minus, and this becomes minus 1x. So just x. So I got 3x minus x, so that leaves me with 2x minus 1 over 2x. I don't know if they had left it like that in the back of the book. What I would do then is, the other way I could do this is I write 2x over 2x over each of these terms up top here. And I have 2x over 2x, so that's just equal to 1 minus 1 over 2x. Perfect. The next question that they ask is, I have x to the 3 or x cubed times x to the 4th. So basically they're testing us what our exponential rules are, or exponent rules. So in this case, if we're multiplying something, we add the exponents. So I get x to the 3 plus 4, or that's equal to x to the 7th. Perfect. Okay, let's go on to number... Oh, I'm at 6? Okay. 2 more, and then I can pass this quiz, right? 7. This one is weird. Arrange these numbers in ascending order, smallest to largest. 8 minus 6, 1/2, 0 minus 4. Okay. 8 minus 6, 1. Okay, so what I would do is, just because I have 8, so I'll write 8 here. I have minus 6. Minus 6 is much less than 8, so I'll write it over on this side. A half, well, a half is between minus 6 and 8, so I'll put that here. I have 0. 0 is between minus 6 and 1/2, so I'll put the 0 here. And I have minus 4. Minus 4 is bigger than minus 6, but it's less than 0, so I'll put the minus 4 right here. There. Done that. If you're confused about that, it's much worse to owe $6 than to owe $4, right? Or $400. Okay, the next thing, it says solve for x. 6x plus 2 equals minus x minus 1. Hopefully there's no more, there's no questions about this. This is hopefully a straightforward review that we've been doing. And hopefully this is something that we should have all seen in 103. To solve for x, we're going to bring all the x's on one side and all the non-x's to the other side. So I have 6. To bring it over to the left-hand side, I'm going to change this from minus to a positive x. And then I'm left with minus 1 on this side, and the 2 comes over to the right-hand side, and that becomes negative. Yep. So I'm left with minus 3, and I have 7x on this side. Dividing through by 7 on both sides, I'm left with x equals minus 3/7. The nice thing about, if you want to know if the fraction is in lowest in reduced form, is that we have prime numbers. If there's usually prime numbers, it's in the smallest form possible. So again, 3 and 7 are prime. So We call that reduced form. What else? Oh yeah, I'm done at 8. Well, okay. Let's see what they're gonna throw us any curveballs on number 9. 9. I have, if x is equal to 3 and y is equal to 9, then square roots. Okay. So the nice thing about this is just simply plugging in the numbers that we're given. We're told that y is 9, so we have square root of 9, so I just put that here. And the last thing that we have is we're told that x is equal to 3, so we can substitute that in. So I have 3 here as well. Square root of 9 is 3. I have 3 times 3. Cancel, cancel. So I'm left with 1/3. If people are worried about the cancellation part, again, I could have done 3/9. And to reduce it, you divide everything by 3. I'll try to save some paper. We'll see. Okay, and the last question, 10. We're told x squared minus 16 all over x minus 4. The nice thing about this is on top here, this is called a difference of squares, meaning that if I had x squared minus, I don't know, let's use a squared, that is equal to x minus a times x plus a. So that's just a common difference of squares. Right. So I can apply that rule so that this x squared minus 16, because again 16 is a square, 16 is equal to 4 squared. I can write that as x minus 4 and x plus 4 all over x minus 4. Now, very similar to what I did over on this side here, I had numbers up top here. I had 3 over 3 times 3, so I could cancel that out. Same thing happens here. Because I've got, I have up top here, I could, let's see, the other way I could do is like this. And that's perfectly acceptable as well. So essentially what this means is that this is 1. So whenever we do kind of cancellations like this, whenever I'm doing something like that, really I'm saying that I can lump these together and these are really just 1. And now I'm multiplying 1 times x plus 4 and it's still just x plus 4. Okay. There's a question. Did he say, or can I ask when the 2 tests will be? I like to track due dates and test quizzes in advance. Right. I did not say when they are because I haven't picked out the date yet. We probably will have one, let's see, around the second week of February, and probably another one maybe first or second week of March. Those are approximate dates, and I have to see. I will announce them at least 2 or 3 weeks in advance when the dates are, of course. And the final exam is scheduled by the registrar, and that's something I can't control. But it's scheduled during the exam block. Okay. So we covered that. We did the orientation quiz. I think I passed. I hope. This is the other thing too. What I tend to do is whenever you're doing questions, make sure to not look at the book, or if you are looking at the book, make sure that you have to do it again without looking. Because on the test, you won't have the textbook in front of you, you won't have your notes in front of you, so you need to be sufficient. The other thing too is that this course is going to be used in later courses in your academic studies. So again, you'll be expected to do these kinds of things routinely on optimization courses and other business courses. So again, it's probably a good thing to get into practicing and that you get these skills down. Right. I was going to check. Did I do it right? Oh, and of course, I was looking at the wrong quiz. Quiz B, yes. 11/14. Good. Good. 4 kilograms of sand. And again, yes, everything else looks correct. Perfect. Oh, we got 4 minutes. Do how many? Let's see, not 4 minutes. I thought I was going to. No, because we started at. Okay. And I don't see why not. Why not go on to doing quiz A? So we have quiz A, and the first question that they're asking is, what is the slope of 3y plus 4x minus 2? So the first thing that you should notice is that this is a linear equation. There's no squares, there's no cubes, so it's a linear equation. And we're used to seeing linear equations in the form of y equals mx plus b. This m here is what we will call the slope, and this is what we call the y-intercept. So for instance, this is the y-intercept. It crosses at the y-axis here. And this is the slope. The slope is the amount of rise over the run. So here's the rise over the run. So that's basically what the slope is. So you can have it's either rise over run, or if I actually had two coordinates here, I have x1, y1, and x2, y2, then this is simply the change in the rise, which is the change in y, over the change in x, or y2 minus y1 over x2 minus x1. But, so this is kind of just the graphical interpretation of that. What we can do is try to get this equation here into this form right here. So I have 3y plus 4x equals 2. I'll bring the 4x to the right-hand side, so I'm left with minus 4x plus 2, and I have 3y, and then I can divide everything by 3 so that I get just y equals minus 4/3 x plus 2/3. And that, ladies and gentlemen, is the slope. So the slope is equal to minus 4/3. Okay. The next one that they ask, what's kind of nice about these quizzes is, yeah, these may sound a little mundane, but it's a good way to recall those concepts that we had covered in 103 before. So again, it's a bit of a refresher. For which values of x is 3x plus 2 greater than 0? The nice thing about this is that I don't have to worry about some weird looking stuff. Graphically, of course, I could plot this. I suppose I could draw this. So the y-intercept is at 2. So right here, I have 1, 2, 3. Sorry, rise over run, right? So 1, 2. Not sure if I did a very good job accurately plotting that, but probably should have been a little bit straighter and probably less than 1. Again, graphing, you know, if you're sketching it, sometimes you're not very accurate. So that's why I'm going to turn to algebra here. I'm going to bring this 2 over to the right-hand side, and I'm left with 3x. And then I can divide by 3 on both sides, so I'm left with x is greater than minus 2/3. And see, I was using this as 1, 2, 3, so these are kind of, I didn't do a very good job. Maybe. No, definitely not. But the x, to solve this basically it's asking, where is this linear function greater than 0, or where is it greater than here? Well, it must occur right at this point, minus 2/3. And basically after minus 2/3, everything on the x-axis here, everything in the y-axis is positive. This one's a trickier one. 3x squared minus 2x minus 1 greater than 0. And again, it's relying on you to kind of know that this is a quadratic. So it means that it has some sort of, it's a quadratic, so it must be either kind of like this concave up, this happy face, or it needs to be concave down. And by looking at the first coefficient here of the quadratic term, the x squared, I can see that it's positive, which means that it must be going up. So I know that it has to be something like this. assuming that it goes below the x-axis at some point. Not necessarily true. I mean, this can translate. We can move it up and move it all around. But the next thing that we can do is, what are these, if there are any roots? So to do that, we can factor that. So to do that, this is a tough trinomial. Okay, whoops, I didn't mean to hit the microphone. So again, we can factor it like that. How do you know this is correct? Well, I can expand that again. So I can do 3x squared minus 3x, and then I can do this bottom bit here. So I am left with plus x minus 1. So I'm left with 3x squared minus 2x minus 1. So that's correct. What does that mean here? Well, to find what the roots are, I need to solve where they're equal to 1 or equal to 0. So 3 plus 1 equals 0. Bring that over to the right-hand side, minus 1, and I have 3x. And dividing by both sides, I'm left with x equals minus 1/3, which means that my root on this left-hand side here is minus 1/3. And this means over here, x minus 1 equals 0, which means that x equals 1. So over here, this is 1. So again, the question is asking, where is this quadratic greater than 0? Well, it's everything that's above the x-axis. So that means everything above here and not down here. So it means that they're looking for where that graph is above the x-axis. So to solve this again, this is when x is less than minus 1/3 or x is greater than 1. And to finish that off, I have written this in a slightly odd notation. You could write this as minus 1/3 less than, oh, no, I can't. The other way that we can write this is using interval notation. So I could say that x is an element from minus infinity to minus 1/3 union 1 to infinity. I have to make sure that these are round brackets. The reason for that is because this says greater than 0, so it can't actually include minus 3 and it can't include 1. The reason for that is because at those points that's actually 0 and we need to exclude them. This is a strict inequality, so that's why we're using the round brackets. If you are worried about me using this, which is interval notation, don't worry, we'll be covering that in the review. That's part of the textbook that we'll be doing. Just a second, let's see if there's... Yeah. We end up covering that in this course as well, so that's good to see. Yeah, let me just switch over to the screen. So again, these are kind of the common. Here's the listing the notations for different intervals. So I have the round brackets, that's the open interval over here. You use square brackets for when they're closed, that's when we have strict inequalities. You can have these half open notations as well. And over on the left hand side here, they give you the illustration for it as well. But again, this is something that we will review when we get back to that section. Okay, so we've hit 5:30. If there's any other questions, feel free to send me an email. Again, thank you for joining me on this platform, live streaming. Again, thank you for being patient and for learning in a different environment than we're used to. This is very odd times. Very, very odd times. And hopefully we'll be able to teach you as good as we can as if we were actually lecturing in person. So again, if you don't feel comfortable using the chat, you can send me emails. Even during the lecture, you can send me emails. I might not be able to see them immediately because, again, they don't pop up on my screen, but I will eventually answer them. Again, thank you again, everyone, and I will see you. Oh, sir, do we still email you if we did not? No, don't email me. I will see why it got hung up, or if there was something. Again, I think I haven't been officially changed in their system yet to section 2. That's or it needs to be updated. Don't worry, I will send out a new email again where hopefully it is working and you will get an email, and that should clear everything up. Again, thank you everyone for joining me, and I wish you a good night, and I will see you tomorrow.